Hi everyone, welcome back to our channel. From this video we will start with plus 1 chapter 1 sets. Soon as we finish with this chapter, I'll club all the videos and we'll be making a playlist of it. So without any delay, let's get into the video. Section 1.2 sets and their representation. So in this section we'll be dealing with what is meant by sets and their different representations. A set means it's a well-defined collection of objects. For example, say the subjects of class 11th. You know that in class 11th what all other subjects, like if it may be maths, English, say physics, chemistry, biology, computer science, etc. Right? So you know it's a well-defined collection of objects. Or say for example even integers less than 9. So we can write it as 2, 4, 6, 8, right? And if you take say 10, does 10 belongs to this set? No, right? It should be less than 9 and should be even integers. Even though 10 is an even integer, it is not less than 9. So well-defined collection means it is in the sense that we can definitely decide whether a given object belongs to this particular collection or not. That is what is meant by well-defined collection. For example, say rivers, we are taking the set as the rivers of India. Does Nile belong to the rivers of India? No, right? We know that the rivers of India contains like Ganga, Brahmaputra, Godavari, Kaveri, etc. So does Nile belongs to the rivers of India set? No. So we can say that Nile does not belong to the collection of rivers of India, while the Ganga river actually belongs to this collection. So that is what is known as set. Set means it's a well-defined collection of objects where we can definitely decide whether a particular object belongs to that particular set or not. These are some of the sets that are particularly used in mathematics, and you can find all these sets widely used in this chapter. So N is the representation for natural numbers. Z is the representation for the set of all integers. Q is used as the set of all rational numbers. R is used to represent the set of all real numbers. Z plus is used to represent the set of all positive integers. Q plus is used to represent the set of all positive rational numbers, and R plus is used to represent the set of all positive real numbers. Sets are usually represented or denoted by capital letters like say A, B, C, etc. And the elements of a set are represented by small letters, say A, B, C, or X, Y, Z, etc. Okay, so if say A be an element of the set A, then we can say A belongs to the set A. See, if A is an element of set capital A, then we can say A belongs to set capital A. This belongs to can be represented by a symbol called epsilon. This is called epsilon. Okay, so we can write A belongs to the set A. If A is an element of the set A, then we can write A belongs to set A, and it can be represented as A with the symbol epsilon, which means belongs to set A. Now if say for example A is not an element of set A, is not an element of set A, then we can say A does not belong to set A. This does not belong to can be represented as this epsilon with a strike over it. So we can write, if A is not an element of set A does not belong to the set A. Okay. For example, say set of vowels in English alphabet. So we know the vowels are A, E, I, O and U. So we can say A is an element of the set V. Let V be the set of vowels in English alphabets. Then we can say this the characters that includes in that set will be A, E, I, O, U. So A is an element of set V. But can we say B belongs to this set? No. So we can write B does not belong to this set V. That is set of vowels. Representation of sets. Sets can be represented in two different forms, roster or tabular form or the set builder form. So roster form, all the elements of the set are listed. What all elements are present in that set, all those will be listed, and they are listed in such a way that all the elements have been separated by commas and they are enclosed within brackets. Let's take an example. Set of all even integers less than 9. So let's write even integers. It can be 2, 4, 6 and 8. So all these are even integers which is less than 9. So see, all the elements of this set are represented, all are listed, and they are separated by using commas and they are enclosed within the braces. Okay, so let's take another example. Set of all vowels in English alphabet. That is A, E, I, O, U. So you can see all the elements are listed and they are separated by commas and enclosed within the braces. So in roster form, the order in which the elements are listed is immaterial. That's not a great thing to worry about. You can write, for example, the set of vowels in English alphabets can be written as U, O, E, I, A. So the order in which the elements are listed is immaterial. And also we can say that not all the elements are generally repeated. That is, for example, say the set of letters forming the word mathematics. So let's say this set as A. So it's a set of letters forming the word mathematics. It is M, A, T, H, E, M is already written, so we are not repeating it. A is already written, not repeating. T already written, not repeating. I, C, S. So in this form, we cannot generally see elements getting repeated in this roster form. So elements are actually distinct, but all the elements will be listed. It does not, the order in which the elements are placed is immaterial, but the elements does not actually repeat. It does not generally repeat, but the order in which the elements are written is immaterial, can be in any manner. If this the set of this letters forming the word mathematics can be written as M, T, A, E, H, C, I, S. Both are same. Both the sets are equal, irrespective of the order in which the elements are written. But the elements does not generally get repeated. So that is what is known as the roster form. So roster form, all the elements of the set will be listed and they are separated by commas. All the elements will be separated by commas and they are enclosed within the braces. That is what is known as the roster form or the tabular form. Now let's discuss on what is set builder. Set builder form, it means that all the elements in a set possess a single common property, while any element that is outside this set does not possess this property. For example, say A, E, I, O, U. This is a set of vowels in the English alphabet, right? So let me write it in this set builder form, that is, okay, In this, the braces are used to represent set of all, and the two dots, that is here, the two dots are used to represent such that. So we can say, okay, the set of all x such that x is a vowel of English alphabet. So we know that all the elements inside the set possess the property that they are the vowels of English alphabet. So any element that is outside this set, say B, does not possess this property, right? It is not a vowel of the English alphabet. So all the elements in a set possess a single common property which is not possessed by any elements that is outside this set. So another example, say the set A, you can write it as, so we can write this as the set of all x such that x is a natural number and the value of x lies between 3 and 10. So what all will be the elements of this set? It will be 4, 5, 6, 7, 8 and 9. So any other elements other than this does not belong to this set, right? So in a set builder form, all the elements in a set possess a single common property, and any elements that is outside this set does not possess this property. Now let's move on to the examples. Write the solution set of the equation x square plus x minus 2 equal to 0. So this is a quadratic equation of the form ax square plus bx plus c equal to 0. So a here is equal to the coefficient of x square, which is 1, b equal to the coefficient of x, which is equal to 1, and c is the constant, that is negative 2. Okay, now we have to multiply. Second step is to multiply c, that is our constant, with the coefficient of x square. We get negative 2 into 1, which is equal to negative 2. Now we have to get the factors of 2. And we have to find two factors such that if these two factors are added, we get the value of b, that is equal to 1. And if these two factors are multiplied, we should get the value ac, that is equal to negative 2. So let's prime factorize this 2, and this least prime number that can divide 2 is 2 itself, giving 1. So there are only two factors, that is 2 and 1. Now the next step is to put proper sign to these numbers. Okay, the thing is, we have to add these two numbers to get 1. So if we are putting negative 2 and positive 1, negative 2 plus 1 gives negative 1, which is not equivalent to b. So this is not the sign that we have to put. Now let's take 2 as positive and 1 as negative. Then it gets 2 plus negative 1 is equal to 1, which is equivalent to b, and 2 multiplied by negative 1 is equal to negative 2, which is equivalent to ac. So these are the two numbers, or the two factors that we have to take. Now we have to split the middle term, that is x square plus, instead b, actually the b is written as 2 plus negative 1, right? So let's substitute b here as 2 plus negative 1, and x is still remains minus 2 is equal to 0. Now let's take x to the inside the bracket. It becomes 2x plus minus x, right? So 2x minus x minus 2 equal to 0. Now let's take the common factors. So let me rearrange this and write x square plus minus x plus 2x plus minus 2 equal to 0. Let me again rearrange and write this as x square minus x plus 2x minus 2 is equal to 0. Now let me take x common from here. It becomes x minus 1 plus 2 common from here. It becomes x minus 1. So let me rub this off. and write, and so x minus 1, x into x minus 1 plus 2 into x minus 1 equal to 0. Now let's take x minus 1 is common from both the sides, so common, so let me take x minus 1 as the common factor. It becomes x plus 2 equal to 0. Let's equate both these, both x minus 1 equal to 0 and x plus 2 equal to 0. So we get x equal to 1 from here and x equal to negative 2 from here. So the two values or the solution to x are values 1 and negative 2. So this is written in the roster form as all the elements are listed and the elements are separated by commas and they are enclosed within the braces. So 1 and negative 2. I hope you understood how to solve the quadratic equation by factorization method. Now let's look on to the second example. Write the set for all x such that x is a positive integer and x square is less than 40. So it is given x is a positive integer and x square should be less than 40. We have to write it in the roster form. Okay, so roster form means all the elements will be listed and all the elements are separated by commas enclosed within the braces. Okay, so let x is equal to 1, then x square becomes 1, that is less than 40. Okay, then x is equal to 2, that is 2 square, which becomes 4, which is less than 40, that is okay. Now x is equal to 3, this 3 square, which is equal to 9, which is less than 40. Then x is equal to 4, that is 4 square, which is equal to 16, which is less than 40. X is equal to 5, 5 square, which is equal to 25, that is less than 40. X is equal to 6, 6 square, which is equal to 36, which is less than 40. X is equal to 7, 7 square, which is equal to 49, which is not less than 40. That means till 6 is our values. So we can write it in the roster form as 1, 2, 3, 4, 5, 6. Okay. Now let's look at the third example. Write the set A equal to 1, 4, 9, 16, 25, etc. in set builder form. So we have to write this set in a set builder form. So we can understand that in the set it is the square of the natural numbers. See, 1 square gives you 1, 2 square gives 4, 3 square gives 9, 4 square is 16, 5 square is 25, etc, etc. So we can write the set A in the set builder form as set of all x such that x is the square of natural numbers. Or we can write it as A equal to x, that means set of all x such that x is equal to n square, where n is a natural number. So natural numbers are starting from 1, 2, 3, etc. till infinity. So here also it's showing from 1, 2, 3, 4, 5, etc. till infinity. So 1 square gives you 1, 2 square gives 4, 3 square is 9, 4 square is 16, 5 square is 25. So we can write the set of all x such that x is the square of natural number, or we can write x is equal to n square, where n is a natural number. Now let's move on to the next example, example number 4. Write the set in the set builder form. So let's see if there is any pattern that exists among the elements of this set. See, 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. We can understand that the denominator part is numerator plus 1. See, 1 by numerator is 1 plus 1. Likewise, for 2 by 3 it is numerator plus 1. 3 by 4 it is 3 plus 1, that is numerator plus 1. 4 by 5 can be written as numerator plus 1, and 5 by 6 is written as numerator plus 1. This also numerator plus 1. So we can write the set. Let me suppose the set as A. For all x such that x is equal to n by n plus 1. Something in the numerator and denominator is that numerator plus 1. Where all these are natural numbers, right? Starting from 1 till 6. Where 1 less than or equal to n less than or equal to 6. Okay. So now let's move on to the next example. Example number 5. Match each of the set on the left described in the roster form with the same set on the right described in the set builder form. So all those on the left belongs to the roster form and all those on the right is the set builder form. So let's start with the first option of the set builder form and let us write them in the roster form. So we can match them. So for all x such that x is a positive integer and is a divisor of 18. So let's write all the numbers that are factors of 18. 1 into 18 gives us 18. 2 times 9 gives us 18. 3 times 6 gives us 18. 4 is not a divisor. 5 is not a divisor. 6 times 3 gives us 18. 7 is not a divisor. 8 is not a divisor. 9 times 2 gives us 18. 10 is not a divisor. 11 is not. 12 is not a divisor. 13 is not a divisor. 14 is not a divisor. 15 is not a divisor. 16 is not a divisor. Even 17 is not a divisor. 18 times 1 gives us 18. So the positive integer and those that are a divisor of 18 are 1, 2, 3, 6, 9, 18. So this option matches with the third option from the left hand roster form. Okay, so A matches with 3. Now next option B. For all x such that x is an integer and x square minus 9 equal to 0. So let's take the square root on let's rearrange this. Let's take 9 to the other side. It becomes x square is equal to 9. Let's take the square root on both sides. X square is equal, root of x square is equal to root of 9, which gives x is equal to plus or minus 3. So this can be written in the roster form as 3, minus 3. So this matches with the option number 4. So B matches with the option number 4. Now moving on to the C option. X is for all x such that x is an integer and x plus 1 is equal to 1. X plus 1 is equal to 1. So taking 1 to the other side, that is from LHS to RHS, it becomes negative subtraction. Here it was addition, so when it is taken to the other side, it becomes subtraction. So 1 minus 1 gives 0. So in the roster form, it can be written as 0, which matches with the second option from the left hand side. So C matches with the second option. Now option D. X is a letter for all x such that x is a letter of the word principal. So let's write it in the roster form. P, R, I, N, C, again I. I is already present, so we don't need to write it again, because in roster form how the characters are written does not matter. The order in which the elements are written does not matter, but no elements will be repeated. So we don't need to repeat I again. We don't need to repeat P again. The next letter will be A and last L. So this matches with the first option. So D matches with the first option. So we can say first option matches with D. Second option matches with C, third option matches with A, and fourth option matches with B. That's all for today's video. Hope you understood the section sets and the representations. If you have any doubts, please do put your queries in the comment box. Thank you.